Okay, we are going to go through the first part of the spreadsheet for KMNO4 titration. So what we're doing this first week is making sure that our concentration of potassium permanganate, which is the purple solution, is close to what it should be. So it's supposed to be around 0.01 molar. So that's what you're going to put in to cell C5, 0.010. In cell C6, we want to know the molar mass of sodium oxalate, and so you just have to go through and add up all the masses, and you should end up with 133.999. Okay, so now I'm going to put in 3 trials. I am making these numbers up. You should not have the same numbers, but your manual does say that you should have between 0.08 and 0.09 grams of sodium oxalate. So that's what I am doing. The closer you can get these numbers to each other, the better off you will be when it comes to calculating relative standard deviation. Okay, now moles of oxalate, you're going to take your mass, you're going to divide it by your molar mass, and how many moles of oxalate are in 1 mole of sodium oxalate? It's 1 to 1. So once you do your mass divided by your molar mass, you're all set. So I'm going to hit equals, I'm going to select my mass, which is C10, divided by my molar mass, which is C6. I need to put dollar signs in front of my C and my 6. And then I'm going to hit, oops, didn't do that right. And then I'm going to hit enter, and I'm going to drag that down. We'll worry about sig figs in a minute. Okay, initial burette reading, somewhere around 0, but try not to make it exactly 0. The permanganate is really hard to read where the volume is because it's such a dark liquid. So I'm just going to put some numbers in here. And then your final burette reading is going to depend on the mass that you started with. So again, I'm just going to be putting in some numbers here. Okay, so you'll have this recorded in your notebook. Net volume is just final minus initial. So equals this final one minus the initial one, enter. And then you can drag that down. Approximate moles of permanganate. Now at this point, we can't use the balanced equation to figure out moles of permanganate. We are using the fact that we think it has a molarity of about 0.01. So we're going to use the molarity of the potassium permanganate and the volume to figure out the moles. Molarity equals moles over volume, so moles will equal molarity times volume, but remember, this is moles per liter, this is in milliliters, so you have to change your milliliters to liters. So, equals, and then I'm going to put in parentheses my milliliters. I'm going to change them to liters by dividing by 1,000, close my parentheses, and then multiply by my suspected molarity. Now I'm going to want to copy and paste this formula, so I'm also going to put dollar signs in front of my C and my 5. Click and drag. Great. Okay, so then this column is ratio of moles of oxalate to moles of permanganate. So I'm just going to go over here and grab my moles of oxalate, and I'm going to divide by my moles of permanganate, and I'm going to hit enter, and then I'm going to click and drag that as well. Okay, let's look at sig figs. Your balance goes to the 10,000th place, so we have to make sure that all of our masses do that. So because these all have 3 sig figs, your I don't know if I can do this. Yeah, I can't do that. Your moles are also going to have 3 sig figs for each of those. There's a little here, let me see if I can drag this up. I don't think I can. No. There's a little button that most of your Excel programs, no matter the version or platform that you're using, should have. And if you click on a box, and then you can make the number of decimals increase, or you can make the number of decimals decrease. That's very handy. So again, moles, you want 3 sig figs. Great. Okay, our burette readings, we always read to the 100th, so these are fine. Okay. When you're subtracting, which is what we're doing here, you always have as many decimals as you have in the number with the least that you're subtracting. So these sig figs are all okay. Moles of MnO4, this should actually have 2 sig figs, and let's just make it 3. So we're going to have these have 3 as well. Usually if you choose 3 sig figs, most of the time you'll be fine. And so then these should all have 3 sig figs as well. Now remember, these numbers I made up knowing what I know about this lab, so yours may not look this pretty, and that's okay. Okay, average equals average, open parentheses, choose those 3 boxes, close parentheses, enter. Standard deviation equals STDEV, open parentheses, choose those 3, close parentheses, enter. That should only have 3 sig figs, so I'm going to go back and do that. And then relative standard deviation will always be, and you're going to do this a million times next semester too, it's your standard deviation divided by your average. This one is in parts per thousand. See that? So I'm going to multiply by 1,000. If it was a percentage, you would multiply by 100. So I got 4.32. And your goal is to get under 10, okay? So you want to get under 10 today. The closer you get to 5, the better. So that was great. And then this ratio will actually tell us, oh, my ratio of oxalate to permanganate is 2 to 5, is 2.5. So if the ratio of this over this is 2/5, that means that this is 5 and this is 2. Now we will have gone over how to balance this in class, so you shouldn't have to worry about that. But after this first week, so this was just kind of a trying to figure out the ratio to solve the balanced equation. Now you also have to go in and you have to put your same masses into these cells that you had up here. So just go right up to cell C10 through 13, copy them, and bring those same masses down here. And you can actually copy and paste the D10 through 13, and you can bring that down to D34 through 36, okay? But here, this is different. You're going to use the ratio that you found up here of oxalate to permanganate being 2.5, okay? So you're going to do equals your moles of oxalate, And then you're literally just going to put times 5/2 because those are the stoichiometric coefficients that will be up here. Okay. Look in your notebook or look in your notes from lab because we will have this balanced in lab today. And then you hit enter and drop and drag. Again, just change all these to about 3 sig figs when you're done. And then your initial and final burette readings, guess what? You can just go right up here and you can actually copy this whole block. How great is that? So E, F, G, 10 through 12, copy. And do the same thing here because it's all the same data. You're not doing it again. And so then your concentration will be not, so this time you don't want to go up and use this one. We're trying to make sure how close we were to that. So what you want to do for concentration here is just do moles divided by liters. Remember that this is in milliliters, so there will have to be a conversion factor in there. So equals moles divided by liters. Well, my answer is not very accurate, but we'll worry about that later. And then as far as average, standard deviation, and RSD goes, you are going to want to do the same formulas that you did up here. We'll go down here. And that's all you have to do for the spreadsheet for after the first week of lab.